Hey everyone, welcome to EthStaker Community Call number 55. This is Jonathan here, and I'm with the EthStaker community. We have a few others from the EthStaker community here also. We have Remy and Hanny with us. So welcome everyone. And then we also have a number of people from the Aztec crew. So we're excited to talk with you all today about what's brewing in the Aztec um, project and world and everything you guys are working on. I don't know that we've had a community call with you all before, so this is kind of like the first time you've spoken with the community, and um, that's a good chance to introduce yourself and the project and what the history of it has been. So that's where we like to start, and also just kind of thinking about what is it that the staking community, e-staker community can be thinking about during the types of things you guys have going on with. I know there's a variety of things with test nets, and we're going to get into all of that. Also, like the approach of the mainnet release. So yeah, I'm excited to learn about this personally, and I know a number of others are too. Um, so with that, I mean, I can just hand it off to the Aztec team to introduce yourselves, and we have Joe, Steve, Lisa, and so yeah, welcome, and I'm excited to hear about what you guys have going on, and just introduce yourselves.
Hey everyone, I'm Joe. I'm one of the co-founders. Yeah, very happy to be here. I think me and Steve may have also swung by one of the staking booths in DevCon in Thailand. So
Oh, nice.
may have met some of you there. But yeah, really great to be here. And yeah, thanks for hosting us.
Hi, I'm Lisa. I'm the COO at Aztec Labs, and I'm also very excited to be here. We did a call with and invited the EthStaker community, I think back in February for a community call on solo staking, and got a lot of really interesting folks in that call. So excited to continue the conversation, especially with Testnet Live now.
And I'm Steve, leading BD at Aztec. Pumped to be here. Love the work that EthStaker are doing. Always super excited to get back involved in the grassroots of Ethereum ecosystem.
Cool. Yes, and so if you were at DevCon, we definitely met there. So that's pretty cool. And that's kind of an interesting plug because we're planning, like everyone's kind of thinking, no, Dev Connect is coming this year, right? So maybe we'll all get together again there in Buenos Aires and um, talk more about all this in person. But yeah, this is great. And so thanks for the intros. And I guess maybe we can get into just the Aztec story. I know that this has been a project that's been um, going through. It has a history, right? You guys have worked on this for a while, and the theme. I mean, we put this in all the like announcements we did on this about it being a privacy and zk built layer two. So that comes with a lot of things, that are kind of unique to this technology that I think we're interested in learning about. And we hear a lot of stuff too about the future of Ethereum being built on these types of tools and ZK being a big one that we hear about a lot. So yeah, I'm just excited to learn like what you guys are doing here with Aztec and what does that manifest look like in reality, right? Like in practice here with some things that we can see and understand what's being built here.
Yeah, maybe I can kick things off on kind of like where we've come from and kind of like our Ethereum journey. Maybe a good place to start, and then we can dive into some of the tech and how we use kind of ZK to achieve that. So we started about 7 and a bit years ago, just trying to use Ethereum to bring real world like financial assets onto Ethereum, and we realized kind of through that we needed privacy for Ethereum to kind of realize its full potential. And so some of the use cases we're going after back then just were a non-starter without strong privacy. There was kind of institutions, sensitive information you couldn't broadcast on a public ledger. And we started kind of initially building this product, hoping someone else would solve the privacy problem. But it turned out that wasn't really going to happen, and we started developing Aztec as originally just an open source project, but we ended up pivoting full time to building Aztec as a privacy layer for Ethereum. And we've had kind of various iterations of that over the last 6, 7 years. The first was kind of, directly on L1, and then we had kind of Aztec 2, Aztec Connect, and now we've kind of, we're entering kind of like our final form. The butterfly is nearly ready to come out the shell, the cocoon, and we've been building a fully programmable private L2. And so yeah, you can really kind of think of it as like an execution environment that has privacy built into its core. You can also do everything public like you can on Ethereum. And it's built as a roll up on Ethereum. And so we kind of use zero knowledge for both privacy and to compress transactions and settle them to Ethereum. And by doing that, we kind of get to augment Ethereum with strong privacy guarantees, but still rely on its settlement and kind of all of the amazing kind of censorship resistance and security that solo stakers add to Ethereum. So yeah, we're kind of excited to be here to kind of talk about what launching that network looks like and what the roles are for validators in the L2 as well, because we intend to launch as a decentralized stage 2 rollup. And so there's kind of the holy grail is that we have people running Ethereum and Aztec at the same time and supporting kind of the same mission.
I'll add to that, Aztec has been working on this for a long time, but it's very cool to see kind of all of the things coming together at the same time that it makes it a perfect time to launch a programmable private L2. There's kind of interest from the top down. You're seeing like Vitalik post about like the importance of privacy a lot. We're seeing it in the bottoms up interest just from like developers looking to build private applications. We have our universal ZK language Noir that allows them to deploy across EVM chains as well as other chains, and seeing a lot of interest and demand from developers to build private applications. And then, of course, like the macro environment just being a little bit friendlier for developers who are interested in this space. So I think it's like the perfect storm of things lining up for us to kind of bring this all to fruition.
Cool. Okay. Yeah, that's exciting. I mean, I think like a lot of people probably listening to this, either, yeah, are probably, experienced in the staking ecosystem in some way, right? With staking, running nodes. And so it seems like there's a number of things that you're working on that would kind of speak to people that have that experience being able to contribute in a new way. I think that's like kind of interesting thing about this, at least from my perspective, is like, okay, we've got these skill sets that people have and are using, and now there's a new way to go about applying that. So yeah, it's cool to hear about. I think like it sounds like talking to this community also is like part of that effort to kind of reach like a distributed, decentralized, set. Like anybody who wants to be node operating and staking in Ethereum is in the staker community is the way we look at it. And so it's like there's lots of different people from like amateur to professional kind of listening and thinking about, how can I chip in and be a part of this, right? So yeah, so like what do you like, I guess where would you guys want to go from there in terms of like
Yeah, I think the ethos is very similar. I mean, I think Ethereum has created this amazing culture of the ability for people to run nodes anywhere based on kind of low hardware requirements and contribute to the network. And we want to kind of mirror that as much as possible with Aztec. We have slightly different things we're trying to achieve with the decentralization, but a lot of the same. We would need to have a large base of validators to help, ensure censorship resistance of the network. We're also kind of giving governance over to the people who run the network, and so validators have a huge role to play in determining how the network evolves over time. And so getting the right people in that community who, care about these decentralized networks is really important to us. We don't want to kind of build like a centralized chain that's, controlled by one company. We want to really make this be a network that can power the world's transactions. And I think you need to have people from everywhere to, voice those different views and make sure the network's evolving in the right ways. So I definitely think that there's a lot of alignment between the types of people I think who are running, solo Ethereum nodes and the people we would like to run Aztec nodes. And that's kind of why we're excited to be here. I think in terms of what it means to run a node, maybe should we go there next, or should we talk more about kind of the privacy side of things? What's a good direction to go in?
I'm interested in both. I think maybe seeing the privacy, like maybe understanding like what this enables, and then kind of getting interest, like kind of seeing the what's new and everything with that would be cool. And then like it would go towards the what can I do with it? Maybe going in that direction. Like how can I be a part of it if I'm a staker or node operator?
Cool.
Okay.
Yeah, I think so the way that Aztec works is we've kind of designed like a new execution environment. We kind of looked at the EVM execution environment, and it's great, but it's lacking kind of the ability to have privacy or encryption as like a first class primitive, and you can't really add that into the EVM after the fact. So we kind of looked at how we could solve this problem, and we designed a new execution environment on the layer 2. We still obviously settle to Ethereum and like are powered by Ethereum in terms of the consensus and security, but Aztec itself is this new execution environment that enables private execution and like private function calls, private smart contracts, and public execution in one environment. And so developers can use that to program these kind of very rich applications that balance kind of the best of both worlds. Like you can have very sensitive identifying information like your passport or bank statements, income, portfolio positions kept private, but you can also have, public DeFi positions. Things like Uniswap can exist where you have like, a public price. And you can code up these applications in our programming language Noir and deploy them to Aztec and get cheap, fast private transactions as a result. And so we're starting to see what we think is a new wave of applications that kind of they can interact with the real world because they provide some of the same guarantees in terms of privacy that Web 2 does that we lost when we went to kind of fully public blockchains. And that's kind of where I think a lot of the exciting innovation is going to happen over the next kind of 5 to 10 years.
Okay. Yeah. So I guess let's see. I'm seeing we did get a chat here. I don't know if we want to take this towards the end or if this is a good one for now, but
I think it's a good one now, Jonathan, because
okay.
it kind of talks to how Aztec got to where we are, kind of a little bit
Okay.
about the backstory.
Yeah,
Like
let's
maybe
start
I
there.
can quickly, yeah, I can quickly talk about that, Lisa, and then Lisa, maybe if you want to comment about the kind of white hat engagement side of things as it relates to that question. Do we need to read out the question
Yeah,
or?
let's restate the question because I think if you're in the YouTube, you see it, but if you're on the recording or the stream, you just yeah, let's read it. So it's kind of like this is from Ryan on the chat saying interested to understand about how the last iteration of the protocol and discovering and responding to the vulnerability, I guess that's what that means, and how they're approaching like exploit safety in the L2 kind of framework format here. Yeah, that's the question.
Yeah, so like that was kind of in relation to Aztec's first product. Like even before that, like Aztec's breakthrough came on the research side. So Aztec invented Plonk, which is so it's research on proving systems, and that basically has been adopted by a lot of the industry now. So Succinct, Mina, zk-Sync, Polygon, all of these guys leverage that research in their products, and that's what our first product also utilized. So that was ZK Money, and ZK Money essentially was a ZK rollup on top of Ethereum, which allowed users to interact with mainnet applications like Lido and Aave with some privacy. So you got privacy around the address and privacy around the data. But there was two challenges on that, and I think that's kind of led us to where we're going today. So one was privacy in Ethereum, and privacy on EVM is just difficult, as Joe mentioned. You get a lot of information leakage around the metadata. And then as well, specifically to this audience, we had a centralized sequencer then. And I think the team's assessment was that it was just far too difficult to decentralize being in that position. So like that's what leads us to like where we're going in terms of Aztec. But maybe Lisa, if you want to chime in as it relates to the story around the vulnerability and the white hat hacker, because that was a interesting period.
Yeah, I think in terms of just how we're approaching security as well and how we approached it for ZK Money, we have obviously done internal audits and then leveraged external auditors to help us kind of dig into the code, make sure that kind of critical bugs were addressed. We also worked with Immunify to set up a bug bounty. And the vulnerability, I think that's being referenced here, was discovered as part of that bug bounty. So a white hat kind of reached out to us through Immunify, worked with us and our cryptography team to address the the bug, and then we were able to address it with no kind of users' funds lost, etc. I think kind of what we're thinking about this time around and what will have to be done differently is one, we've built out a larger security team since then. And so we are kind of adding more resources and bandwidth to our team to kind of do those internal audits, and then obviously continuing to work with like the best external auditors, and then we'll also have a bug bounty for the L2. And the execution environment is kind of where most of the surface area is in terms of like what's new and novel. And so we will be kind of making sure that we're allocating enough time ahead of mainnet launch to have extensive kind of security reviews, both internal, external, and then setting up a bug bounty. So kind of all of the standard things. I think the one thing that will be different is obviously last time, as Steve mentioned, we were running a centralized sequencer. And so the way to patch vulnerabilities was, could be done internally. This time, which is like related to the call and kind of how we'll be addressing these things going forward, is it'll be a community of sequencers that will have to upgrade the network collectively through our governance process. And so in terms of how we're approaching it that way, it's really important that we have sequencers that are actively involved, engaged, responsive, et cetera, so that we could respond quickly to these things if they should emerge in the future, to make sure that the upgrades are happening in a timely way so that users' funds are safe.
Yeah, I think I can add as well, like the previous versions were kind of like you could view them a bit like an app specific rollup. So the vulnerability was also kind of like in an app. Whereas like right now, like the next version of Aztec is fully generic. So it's like we're concerned about there's gonna be two types of vulnerabilities. There's gonna be vulnerabilities that happen in developers' apps, and then there's like vulnerabilities at the protocol level, and they warrant kind of different responses. I think a lot of applications in the early days that will be kind of the foundation and the team are looking for developers to build. They won't be applications that require like huge TVL. Like we're trying to go after this type of application that's either more social or it leverages TVL on another chain, and then the effect of kind of a bug is more, it's reduced in terms of like is it worth going after an obscure zk vulnerability in Aztec if there's not much TVL at stake, because it's all kind of transitory capital. And so the approach we're taking to kind of launch is figuring out which applications really need privacy, but they need privacy in maybe an identity way, or they need it in a way where the loss of funds from a bug kind of being exploited doesn't really exist on Aztec. And so combining kind of that phased approach with just much larger bug bounties, and I think since 2020, like the industry's come a long way in terms of auditors, in terms of familiarity with zk tech. We feel more confident that a lot of these bugs will be caught, but with all cutting edge tech, there's always a risk. And I think, yeah, as Lisa said, that's where a good community comes in to kind of respond as a last resort.
Okay. Yeah, I think it's there's a number of questions here. I think it seems like about like, okay, what does it look like to interact with this kind of technology? Like like you mentioned, like social capabilities or like identity tools. I think Steven, when we were talking once recently, you were talking about how there's some capabilities around, if you think about like a passport or something where you're proving one thing without giving all the rest. Like, I mean, there's a lot of different analogies I think I've heard about zk tech and like what it means to actually interact with it and benefit from it. But I'm just curious, like if there's things you guys have seen in terms of those apps, and like the kinds of experiences it's creating.
Yeah, I can kind of list a few. I think the high level mental model is that you can take things in the real world that you already have that you wouldn't want to put on Ethereum, and you can now use them in a blockchain context. So that maybe kind of something to do with your email address. Like Steve just posted an app. This is just using Noir actually, so it's just using kind of zk on its own, but you can prove that you have an email from a given kind of email domain, like a G Suite domain. And as a result, you can kind of access an anonymous kind of like messaging board. And so, you can see messages from people with an EthStaker email. If you guys had like a kind of an EthStaker kind of address, you could use that as gating for a forum and collect community kind of messages that you know from the community, but you don't know who, so people can speak a bit more freely. So that's kind of like one type of application. You can kind of apply the same thing to passports, even kind of like bank cards. There's a lot of cryptography in the real world that has been inaccessible to kind of Ethereum as a public chain, because it's either, you know, on different elliptic curves, or people don't want to broadcast it to the mempool. And really what kind of Aztec enables and zk enables is you to access that cryptography and do it inside a private context almost, and then have the result be affected on chain. And so yeah, we're seeing that across emails, passports, even just basic things like games, like people building games where there's some hidden information between two parties. You need privacy to play that game on chain. So I think there's a pretty broad spectrum. Some of the flows that I'm most excited about are kind of the cross-chain flows that we created with Aztec Connect, but now 2 years on, like there's now L2s with lots of kind of different TVL. We're thinking about how we can leverage bringing privacy to the whole like Ethereum ecosystem. And so to put this all together, like you could have a passport gated pool on Arbitrum Aave, and you could like put funds into it from Aztec, but you're actually, the capital's on Arbitrum, but you've managed to enter that pool that was kind of whitelisted, or like it was a kind of real world asset in the pool. So you needed to do some sort of check to get into the pool. You can do that check with full privacy, and you can like bridge from Aztec into that pool. Is like a really exciting flow that we're kind of looking to build out around the mainnet launch.
Cool. I feel like I'm jumping into some of the questions already, like, maybe prematurely even. So, that's how these things tend to go. We kind of go wherever the conversation takes us. Um, I feel like Remy, you added this question. Do you want me to ask this one, or are you in terms of
Go
the
ahead. Yeah, you can ask it.
private, in terms of like things being private, how should people think about like, okay, how do you know if the thought process is everything's private? Like, is there a proof that's happening, or is there some way to know when that someone isn't just out there creating, some tokens or ETH on Aztec? Like, what are the assurances people have in this type of environment? And yeah, like, would it be visible in some way? Like, maybe this is a nice segue too into things like proving and sequencing. I don't want to pretend to say that that's what that's about, but like, are those providing some kind of um, capabilities that help with this question?
Yeah, it's a good question. So I think we can look at kind of what is a proof maybe, and how we use them to try and answer it. So it's, I guess the first thing I'll say is it's up to developers to kind of choose how to use that privacy. Like I think like a completely private app when no one can see anything is actually not that useful. Like like the most interesting apps have some information disclosure, but some privacy, and that balance is kind of how the real world works. Like to be on the call, I have to say I'm Joe. But like if I was just like faceless and I didn't say anything, it would be a pretty boring call. So I have to give some information in everything we do, but it's, I'm not coming on the call and holding up my passport. So I think that's kind of the right mental model to think about proofs in terms of like an Aztec transaction. So when you interact with a smart contract, you create a proof for the private portion of that contract. And so what you're actually doing there is, compared to a normal like Ethereum transaction, so in a normal Ethereum transaction, you're asking a node to execute on your behalf. You're saying, here's a signed request from Joe's private key that I want to give a min 1 ETH. And then you ask a node to execute for you, and then all the nodes basically check it. In the proof model, that execution happens locally. And so on my device, I will execute, come up with the resultant state, and then I'll prove using a zero-knowledge proof that I've done it correctly. And then, the magic happens when we take that proof into the Aztec network, and we aggregate it into a rollup and validate it on Ethereum. And so the guarantees you get come from when that proof is validated by Ethereum. So your Ethereum node that you're running is actually kind of verifying the Aztec transactions, but it's doing it in a way where it can prove that the transaction was executed correctly, but not reveal the secret information inside the transaction. And so it sounds a bit like black magic, but that's kind of the magic of ZK and what these proving systems like Plonk enable. And so I think, to make that useful, there will need to be some checks and balances around, how did funds get into the system? Like some funds will come in from, L1, and you'll be able to see how much capital is inside a given pool. You'll be able to see kind of, this pool has 1,000 ETH in it, and that the source of that is from L1. Other capital may come directly from Web 2. It may come from like a centralized exchange, and there's different kind of controls there where they know what's in the pool, but it's up to kind of the ecosystem to mix and match a bit. And yeah, I think maybe segueing into kind of like what that means for the network. The Aztec network is kind of made up of these transactions which contain little zero knowledge proofs, and then potential public execution requests as well. And so the role of a kind of node operator or a validator is to, there's a peer-to-peer network that propagates those transactions. And then people who are in the staking network, much like Ethereum, will be selected to propose blocks, based on a random kind of leader election algorithm. You'll propose a block, and other validators on the committee will attest to your block being correct, and attest to the fact that it can be proven. And so those attestations are basically execution pre-confirmations. They're basically saying to users, this resultant state should be proven, and it gives a little bit of economic security. But we wait for Ethereum to actually validate and get full finality once the ZK proof lands. And so our validator network is kind of this rotating group of people who take it in turns to propose blocks, attest to the fact that the proposed block is valid and can be proven, and that's kind of how the L2 network creates blocks in decentralized fashion. Amin, do you want to maybe talk about some of the requirements for the nodes and like what we've been seeing on testnet?
Certainly. Yeah, today, I think a driving factor in kind of the development of the Aztec client has been to just keep it really accessible. And then following in the footsteps of Ethereum, today any machine that can run an Ethereum client, kind of like Geth or Reth, can also run an Aztec sequencer. And what we're seeing on testnet is people are running with like just 4 cores, 8 or maybe 16 gigs of RAM, and just like under really a gigabyte of storage today on testnet. If you want to run your own Ethereum nodes alongside an Aztec sequencer, you'll probably need 1 terabyte of storage. So the requirements are not, these are very accessible machines. I think everyone that's ever run an Ethereum client kind of has that capacity at home. I think maybe some of the, like where the L2 requires some performance, I think would be in the data transfer and the bandwidth. And even then today on testnet, this is still under 25 megabits a second, because, we're on testnet and throughput isn't that, I wouldn't say it's that high, but even as the throughput kind of is expected to scale, we think that the bandwidth requirements will still be significantly lower than kind of some of these other ZK networks that you're seeing out there. I want to maybe just going back to what some like kind of what Joe touched on like really the role of sequencers and like the block production in Aztec. Today, anyone can run a full node on Aztec, but the validator set is a bit gated at the moment for testnet. Today, you can still permissionally access the set, but we're limiting that to 5 during testnet. The reasoning is there's no Sybil mechanism. Like on mainnet, there's like proof of stake. Aztec is a proof of stake network. So there's proof of stake, which is a Sybil mechanism. It doesn't work on testnet. So unfortunately, we have to be a bit protective of like who joins the validator set, like which nodes get to kind of actually play a part in creating blocks. Joe mentioned that, the sequences set, the job of the sequencers in Aztec is to give you kind of fast pre-confirmations, right? When you post a block, when the sequences set post a block on Ethereum, it's telling you, hey, this is, to quote Joe, this can be proven, this state update can be proven. And then eventually, after some lag of time, only about 20 minutes actually in Aztec, provers will land a proof that will be verified by all Ethereum nodes that will say this is a correct state update. The reason why the validator job is kind of a bit it's a trusted role, and in a permissionless setting, it's kind of like you have to have checks and balances, because if you think about a fast state update, think about think about a regular kind of optimistic L2 on Ethereum. When it posts a state update, you're really trusting the sequencer, right? Like in an optimistic rollup, there's like a 7-day finality period. But whenever a state update lands, you're trusting the centralized sequencer by saying, okay, this state update is probably true, so I don't need to really worry about it. But in a permissionless setting, if any sequencer can just post any state update without being proven, you don't really have that same level of trust. Like, remember, this is the permissionless setting. This is kind of where in Ethereum, the entire network has to kind of attest to it. In Aztec, we have we select a subset of the entire validator set. This is called a committee. The committee is about 48 of these validators, and then we require 2/3 of those validators to basically say that, yes, this state update is correct. And so this gives you more confidence that it's not just one sequencer that, again, like may have, you don't know who the sequencer is. It's not just one sequencer, it's more of them that, that have attested, that have said this state update is valid. And so, yeah, this was kind of clarifying, like, what is this economic security that Joe was talking about? It's really, it's not one sequencer that is, again, stake, because it's proof of stake. It's about 2/3 of 48, which is at least 33 of them that have given you kind of their stamp of approval. You can trust the state update. So yeah, so in summary, I would say the validator role is pretty crucial to block production availability, to kind of just like following the fast chain in Aztec. Today that's gated. If any of you on the call are kind of curious about how, what does decentralized sequencing on day one look like for a rollup on Ethereum, today we're live on Testnet. We have Alpha Testnet that's been live for quite some time now. Please come into the Discord. If you're from EthStaker community, we're happy to get you started on a validator role. The requirements are really not that much at all. I think most of you will be able to kind of run that machine at home. Yeah, and this is kind of the map that you see on the screen is really a result of the effort of the team. Like, there's quite a lot of engineering that has to go to make, a sequencer in like Tokyo send a block proposal to like someone who may be in like the other side of the world in New York. The validator in New York, you remember that this 48 committee must like receive the proposal, execute everything, return it all in time to be kind of for the transaction and the contents to land on Ethereum. So we're pretty excited about this, like 15,000 nodes in really a decentralized geographic, like the geo dispersion of these nodes is incredible to see. And out of these 15,000 nodes today, we have about 800 of them that are in the validator set. And every about 20 minutes, 48 of them are kind of picked randomly to perform this kind of protected role of like signing off on the transactions on the network. So yeah, just to conclude, like, hope to see more of you on the Aztec Discord. We're trying to get that number from 700 to 2,000, and yeah, with your help, we can get there pretty fast.
Yeah, I can talk a bit more maybe about kind of both the map and also we have a dashboard that someone in the community built. We just got it 2 days ago that kind of talks more about what the role of the validators is. So maybe it's helpful to share that and kind of go through, see what this looks like visually, because I know some of it can be quite technical. Just on like how to take part, I think, yeah, join our Discord. There's a run an Aztec node link on the map as well, which will send you to our docs and kind of help you get started setting up your node. And then, yeah, if you reach out to them or wait till next week, we'll have a more permissionless flow that you'll be able to try to just join the set yourself. In terms of kind of what the kind of what the committee does and what it looks like to actually propose a block, and maybe also why we need to limit the set on testnet, we can look at this dashboard, which kind of, it has kind of people's validator performance, like their attestations, how many blocks they've proposed. But we can also go into the current committee of 48 people, and we can see at the moment the network's not in the most healthy state on testnet, where the green kind of like lines are, where an attestation's been received. the gaps and the red lines are where it's been missed. And so on testnet, like, there's no cost to kind of like setting up a node and like turning it off. Like if you do that on Ethereum today, you'll either have an activity leak or you'll be slashed. And so the current stage of testnet is a min is the slasher, but the next upgrade will be testing out the slashing mechanisms and making sure that these all work for a mainnet setting. But you can kind of see here the effect of having inactive low quality validators is that we skip some blocks. We're not at the throughput that we could be because some validators are not online, or we have someone propose a block, but we can't get enough attestations because some of the validators in the committee are not responding. And so, yeah, we're kind of, if you have experience running nodes and this stuff is exciting to you and you want to learn about kind of slightly different L2 proof of stake networks and how those work, we'd love to have you kind of dive into the Discord and start a testing and helping us beef up the quality of the validator set so we can add more and more high quality validators.
So is that what you guys mean when you're saying, it'll move to an adversarial test net? Is that where it's like in protocol slashing basically and that whole logic playing out? Okay.
Yeah, so
That
there's a
makes
few
sense. Seeing
things.
it illustrated like this helps it make sense, I think. Yeah.
Yeah, you can kind of see the different, these are kind of like the 32 slots in an epoch. So we're currently on, slot 18. Each slot's about 36 seconds. It's three Ethereum blocks. Eventually we'll reduce these once the network gets kind of more stable. But yeah, at the moment it's just testing all of this working is kind of the goal. And yeah, if we can't get the attestations we need in the time, the block won't be proposed. And so we'll skip it and we'll, have transaction backlogs as a result. I think the kind of interesting thing this dashboard can also show is it's tracking kind of some inactive validators. Like, so these people would be slashed in the adversarial version. And the way slashing works is it's a vote actually by the sequencers. So the node software is kind of configured to say recognize certain inactivities, but one sequencer, as soon as they see that, will start proposing a vote to slash them in, as an example. And if enough sequencers see the same thing, they'll also vote for it. And then will either be fully slashed, kicked from the set, or maybe a partial slash, depending on the severity of his actions. So yeah, at the moment the network's been, up and down. Like we had probably 3 weeks of very, very high quality block production. We've been growing the set recently, and as we do that, we've had some missed attestations. But yeah, I think with the right more experienced solo stakers, I think we can grow the set with high quality operators.
I have a question regarding the economics. How does it harmonize with Ethereum staking? Isn't there a risk of reducing security on Ethereum if all of the stakers move to Aztec?
It's a good question. We need both really. So like ultimately you're staking different assets. So that's kind of like one thing I would say. But yeah, because Aztec is a roll-up that relies on Ethereum for its security, like the ideal solution is that yeah, you're kind of you it's not either or. Like we're kind of adding to Ethereum, and yeah, to do that you have to stake in both places.
Right, I'm just thinking like if I'm a rational actor and I have to choose which one I'm staking on, I would obviously pick the one that pays more. So
Potentially, but I would imagine it's like a way to you have some potentially idle capacity on your internet connection and machine. And if you have some kind of that you're willing to do this, you can do both and potentially better use that capacity. So if you've got a 16 core machine that's like got a bit idle, just sitting there, you can run both. And that's the hope, because then you're validating both networks, which are pretty symbiotic because Aztec needs Ethereum, and you're contributing to both networks in the best possible way.
That's a fun one. And then it becomes a question as to whether you want privacy on Ethereum.
Yeah, it becomes how aligned are you with the Ethereum roadmap at some point. But I do think that there's, if you were to think about just running an Aztec validator on your own, you would have to pay for an RPC. You'd have to pay for like all of these things that you kind of get for free if you're already running an Ethereum node, because you can just link it to your node on the same box. Yeah, maybe just to go back to maybe a proving point that Amin was mentioning. So yeah, what will happen at the end of this epoch is once all the blocks are in, we'll kind of, we'll see how many transactions there were. Provers who are looking at the network will take these we call them block proposals in the epoch, and they'll aggregate them into a proof. It normally takes about somewhere between 10 and 15 minutes to generate that proof, depending on how many transactions are in there. And that will be submitted to Ethereum as a ZK proof. And then all the Ethereum nodes will execute that transaction and validate that all of the transactions in all of the slots contained in that epoch on Aztec were valid. And so on Ethereum, that proof is probably taking about 1 to 1.5 million gas at the moment. And so we get a lot of kind of scaling and compression by doing that. And there's also a lot of data going into blobs to kind of broadcast to the world what's happening inside these transactions and make sure that the next sequencer has enough data to reconstruct the state tree and propose the next block. A lot of the data is encrypted, so to the rest of the world it looks like garbage, but if my data is in there, I can decrypt it and find my balances, which is really cool. So in terms of kind of like economic alignment, not on the individual sequencer level, we pay a lot of rent to Ethereum for the services we provide. So I think there's also a lot of alignment there. We pay both for kind of the blobs and also the execution of the proofs when they're submitted.
And the staking and governance is on mainnet as well. So if you don't like what Aztec is doing, you can have your say.
Yeah.
Is there do you guys have like a roadmap or timeline in place for these phases? Because it sounds like adversarial is next, then mainnet. Like it sounds like maybe people just need to keep their ear to the ground to keep hearing more about that and spend time with the community in the Discord and whatnot. But I don't know if there's anything like general kind of broad strokes that you have. And I see that I'll just, before you answer, I'll also say that there's a number of links being shared. We're going to try to get all those to people in the chat, including something about, like getting set up or, exploring next step on this for anyone interested. But yeah, on that question I had, is there anything in terms of like how people should think of the next month to 2 to 3 to whatever months you guys are looking at for this year?
Yeah, I can take this one. So I think the main goal with adversarial testnet is to kind of test out all the remaining, protocol features that are needed to go to mainnet. And so, we're kind of, if all the validators are high quality, I think Amin's best estimates are 2 weeks, but it's probably going to be like more like 4 weeks of kind of testnet. We'll then kind of go to audit with the kind of like mainnet contracts, and we'll deploy a version of the protocol on mainnet that doesn't yet have transactions. So we kind of call it network ignition. It's really trying to bootstrap the validator set and test that the block production works in a mainnet setting. Like we've done a lot of tests on Sepolia and various test networks, but it's always different on mainnet when you have to pay for gas and you have to kind of compete for blob space. And so we'll then run a network on mainnet probably for 3 months that is just further testing the block production, and then we'll launch mainnet towards the end of this year, where there'll actually be transactions. So yeah, there's a lot happening over the next kind of 6 months, but that's kind of like a rough indicative timeline. And yeah, the testnet's kind of the most fun stage because it's changing every day, and there's always things happening. Like some days we'll have perfect block production, and others, people will be slashed. So lots of that happening.
Think of it, to me, that's like the bleeding edge, right? Like where do you see the tech actually evolving and the any crazy stuff happening?
And you can contribute, right? Like some
Totally.
amazing person in the community built that dashboard, and now we're showing it here. So like I think like we love just people's contributions, and I think that's what part of a truly decentralized network is. It's like taking things from the community and everyone building it together.
Totally. I'm just doing a time check. We're kind of in like the last quarter of this call right here, but I wanted to make sure. Yeah, I think we're getting some questions here about people just thinking like operationally. I mean, like stakers, are probably really familiar with their setup for what they do and the different types of things they do. And I think one thing I always think of with ZK Tech is like that there's something of like a power component even involved like proving takes power and even some time or something. But I mean, one question here from SNX on the Twitter is, or on YouTube, is like, is there a stake? What's the stake to run a validator? I guess, is there anything that you're able to share, or is it something for people to learn more about in terms of like those requirements, or what can people like understand there for starters? Or is it even, yeah, like how much is known at this point?
Yeah, we're still trying to work out kind of what a reasonable like stake amount is. Like there definitely needs to be capital at stake for the validator role, because as you can see from that dashboard, you can misbehave. Yeah, I think we're still trying to flesh that out. I think it would be significantly less than like that to run an Ethereum node, just given what the role of a validator is doing. Like on Ethereum, you're providing full economic security for all transactions on the network. On Aztec, you're providing pre-confirmations, and so I think the thing we really care about is censorship resistance and those pre-confirmations. And so I think the stake per validator can be a bit less. But yeah, we haven't come to final numbers yet. I think as part of Testnet, we will be doing that, and we'll publish more when we have it. Yeah, I think the only other thing I would say is kind of on the electricity kind of requirements. There is another role, like the proving role, which is fairly resource constrained. That's also permissionless. So like if people are watching and they want to give it a try, like we're more than welcome. We have about, I think, 10 provers on the testnet so far. That role is kind of much more you can't really do as much wrong. You just have to show up, have a lot of machines, and grind out a proof. And so in that kind of model, you're basically being paid for compute. In kind of the validator model, we care more about who you are, your values, and like, do you want to be a part of the network? And that's kind of what we're looking for. And it's less about compute and machine requirements. It's more about you and the person behind the machine being part of the network. Obviously, you have to fulfill your duties as a validator, but the ethos matters a bit more. For the proving side, yeah, the only thing you can do wrong is not show up. And so the model's a little bit different there, where we just try and incentivize multiple provers to show up. And so, yeah, those are kind of the two main roles. But I think there is an electricity cost in the prover model, but it's mostly machine costs, like on data centers or your own hardware.
Mhm. Were those on that dashboard as well, or is that I don't know. I'm just wondering if it's like sliceable by provers and validators and sequencers, or what exactly, or is it, yeah, or that was nodes, I guess, right? Being shown.
Yeah, that was nodes and validators.
Yeah.
I think provers, I mean, Amin maybe has more context, but yeah, they need lots of machines, but they're usually kind of just on a rack somewhere, and like
Hmm.
they're not really, they are a critical network role, but like if we have one proof land on Ethereum, that's all we need. So one is not very good redundancy, so we incentivize more, but we don't need thousands of them, because beyond a certain point, it's wasted compute.
And the requirements to run a prover are just far different from what it takes to run a sequencer. You mentioned a sequencer is like, think of any machine that can run an Ethereum client. You can also run an Aztec sequencer most of the time without any additional, without you buying any additional storage, RAM or CPUs. For provers, like right now, I think the minimum that you would need is about maybe 10 to 12 machines, each on 8 cores. and like something like at least 60 gigs of RAM. So they're pretty juicy machines, and that number is expected to go up as the throughput goes up. But those proofers leave the proofs on Ethereum. Like those proofs are verified by every Ethereum node. We post them to Ethereum. And so if you go to the rollup contract, you can see the provers submit proofs to Ethereum. They're not on the dashboard yet, but yes, they're sliceable, as you said, kind of by provers and sequencers. You can, yeah, look at Ethereum and then you'll see them.
Cool. Yeah, it's definitely a different part of the architecture that, I mean, in classic Ethereum staking, we are not, as I don't think, at least I'm not as familiar with it, but like unless you've spent time with something like Aztec or um, this component of the ZK architecture. So it's pretty interesting. Yeah. So yeah, it's one of those things too with this topic of ZK where I feel like every like few weeks or so, I feel like there's some kind of new update where somebody's like, look at this advancement that happened in ZK tech, and maybe like a general, just kind of picking your brains on that topic. Like what are the things that are exciting you guys in ZK tech, or what as far as like new things, or like how do you keep up with it? I don't know. Like how do you keep up with the evolving industry on this stuff, and with building a project in that also, I imagine that's an interesting place to be.
Yeah, I mean, I think we're quite fortunate. We've got Zach on our team who's helped create some of this. So he keeps our fingers to the ground on kind of ZK like innovations. But I think the things that we care most about at Aztec though are any developments that make more proving feasible on client devices. And so, as I talked about kind of earlier, like the private side of a transaction is executed locally and proven on your device. And there are some constraints there, like how long it takes, memory, those sorts of things. And so, as we see new kind of innovations in ZK come on, we're always looking to see if like any of those kind of advancements can be added in to make more complicated transactions provable faster on a phone, for example. We have pretty good support for like mobile proving like natively, but there are some limitations in the browser currently. So that's kind of one area we look at. I think the other area is, there's been some initial work looking at the rollup proving. So there's also like the aggregation of all the transactions into a ZK proof to settle on Ethereum. There's been some early kind of exploration into GPUs there. So currently the provers are all CPU-based machines, and for some of the proofs, you may get some decent speed ups by making them run on a GPU. And so that could help either reduce the cost to prove or make it accessible to more people. So those are kind of the two areas we've been looking at. And then the other side, I think, is just like looking at all the projects using ZK, which I think is, I just think it's exciting. It's like this new horizon of applications that are being built. So sometimes they're built with Noir, which is great. Like that's the language that powers kind of Aztec, and you can do that on any kind of EVM chain. But any ZK application, I think, is helping develop the new mental model of how to build these applications that have privacy built in, because it's a slightly different programming paradigm when you're proving something versus like asking someone to execute it. Maybe it's a good segue actually to one of the questions in the chat about kind of proof of innocence and
Oh yeah, let's make sure we get to that one.
so yeah, we have a few teams building similar things. They range from kind of implementations of the proof of innocence kind of protocol through to kind of proof of passport and other forms of kind of identity verification. But
Yeah, and just to restate a little bit what this question is saying is like demonstrating that validators are not like responsible for laundering, North Korean hacks or things like that. Yeah.
yeah, so I think at a high level, like I guess two things happen. One is like for some transactions, you can't see what you're executing. So like it's like an IP model where like ISPs are not responsible for the encrypted traffic that goes through them. But then for the public portion of transactions, you could kind of make some distinctions, and you're free to decide what to do there. How we handle it, or how developers handle it at like the application level is, yes, applications can absolutely build in these things, and we have a lot of teams kind of building both proof of innocence, passport proofs, those sorts of things, but it's more at the application level. And so you can kind of you can use a set of applications that use only proof of innocence funds, other people who may use like Coinbase approved funds. And like I think the reason that Aztec actually is a fully decentralized network is that there's not a gold standard today on what this will be. Like Coinbase will have a different set of ideas on what's needed to proof of innocence, for example, and we want both to exist and kind of developers and innovation to really figure out what ultimately is needed to protect users. So yeah, the high level Aztec can support all of it, and yeah, it's going to be exciting to see, I think, how innovation kind of like where we end up as a result. But from a sequencing standpoint, yeah, I think you're fairly safe as you at that point you can't see what you're executing.
Okay. Well, we're towards the end. Yeah, we have like less than 5 minutes left. I don't know if there's any other last minute YouTube chat questions or I know that there's been, like I said before, there's been a number of links. We'll make sure that we're getting those to viewers and like a form. Join the Discord. I mean, you can go to the Discord, interact. Say you came from the EthStaker conversation, but there's a form too that we can get in the hands of listeners also for taking that next step, just to kind of raise your hand there for anyone interested. So yeah, if there's anything else that you guys want to say before we sign off, we do a POEP before we end, just to kind of for people to collect if they've made it this far with us in the conversation. But is there anything else you guys want to call out before we go there?
One for me. Yes, please come run an Aztec sequencer. Come to the Discord. There's actually a lot of the time we're running like some very fun activities to kind of get people more familiar with how block production works in Aztec. If you're from the EthStaker community, we'll get you to bypass the quota and like straight into running the validator role. So yes, come find me in the Discord. We'll run sequences together. Thanks.
Cool.
Yeah, I'll just add on. We will have adversarial testnet soon, which will be more streamlined in terms of onboarding. But in the meantime, we have this link so you could share your address, your Discord handle, and then we'll get you into the right channels. We'll onboard you into the set really easily, so you don't have to kind of wait in the queue that we mentioned earlier. So encourage you to fill that out so that we can make sure to get your information and get you in the right places.
Cool. Okay, nice. So yeah, a good few clear steps there for people to participate. So thank you all for joining. Really appreciate like the time and kind of education here. I've certainly learned a lot. So and fielding all our questions, you never know what kind of questions are going to pop up, right? So but it's really cool stuff to hear about here. Remy, if we can put the POEP on the screen, we can just make sure we get that information out there.
It's on, yep.
It's good to go. So we have a POEP here that's for Aztec Community Call 55, and it's the same type of airship mechanism that we've done before. So you send 0.001 ETH to the poep.ethstaker.eth address, and just do that in the next couple of days. I think it's going to be open through June 7th, through the end of the day there, and the payment will be accepted on Arbitrum 1, Base, Optimism, and Ethereum mainnet. And yeah, and these are supported and powered by Arbitrum 1. We mint them on Arbitrum 1, so like to call that also. But same as before, so collect that POEP. And thank you, Aztec team, for joining again. Really appreciate the time with the community here. So if anybody has like suggestions or topics or yeah, wants to give a talk at DevConnect, we're actually accepting applications for that now for the live in-person staking gathering event. So it'd be cool to have either the Aztec team here or anyone listening apply and reach out to us to get involved with that. Should be pretty exciting later this year. It's going to come up quick.
Yeah, we're looking forward to it on our end. So hopefully see you guys there.
Awesome. Sounds good. We'll talk in person there. All right. Well, thanks everyone. Thanks for joining the stream.
Thanks, everyone.
Thank you. Bye.
Bye.